Okay, let's get started. Today I'm going to talk about my research topic and research design, namely the non-destructive testing. Non-destructive testing is a method used to detect the inner defects of materials without damaging the components. In some cases where the inner defects of the materials needs to be tested, the non-destructive testing is essential because both clients and manufacturers do not want to damage the components while testing the quality of the materials or components, which embodies the importance of non-destructive testing. I'm sure you may be not familiar with the non-destructive testing. After I make a vivid comparison, I'm sure you will know it. It is known that during physicals, we need to conduct X-ray inspection and B scan. These two methods are equal to radiography and ultrasonics. The only difference is that is the subject. During physicals, the subjects are the human beings, but in the non-destructive testing, the subjects are materials or components. There are three main methods for non-destructive testing, namely radiography, ultrasonics, and magnetic particles. In terms of magnetic particles, there are two main forms. The traditional magnetic particles uses magnetic particles to detect the inner defects of the materials. The only requirement for this method is that the materials to be tested must be made of ferromagnetic material so that it can meet the requirement of inspection. However, this method cannot give us the qualitative analysis of the defects, which becomes a major research topic. Secondly, the magnetic memory uses the residual magnetic stress to detect the defect inside the components. However, it cannot guarantee the same exact results as radiography, which embodies its limitation in this field. In light of radiography, the traditional radiographic method uses the difference in density as well as projection to test the inner defects of materials. It is good at detecting the volumetric defects. However, the depth of defects cannot be gained by only the traditional radiography method, which is a major research topic for many professionals in this field. Another advance as technology advances, some advanced radiography has been put into place in recent years. However, due to the fact that the radiography is radioactive, so that many researchers and professionals have been trying to find a way to replace it by using other methods. The third commonly used non-destructive testing method is ultrasonics. The traditional ultrasonic method is good at detecting both volumetric and planar defects inside the materials or components. However, the near-surface defects cannot be accessed exactly due to the interference between the transmitted and the received pulses in this area. So, two other advanced ultrasonics have been put into place due to the limitation of the traditional ultrasonic method. The time on flight time and the phased array method are both based on the traditional ultrasonic method, but they can put the image onto the computer screen, which makes the testing more efficiently and effectively. As I was saying previously, the radiography is radioactive, so many researchers and studies have been done in order to eliminate this drawback. So my research question is also involves this topic. Can radiography be replaced by a combination of advanced ultrasonics methods in detecting defects in welding? Since I will focus my research design on welding, so let me first introduce the four mainly used welding methods in the various industries, namely submerged arc welding, CO2 shielding gas welding, electron beam welding, gas tungsten arc welding. Also, I need to introduce 6 main defects commonly found in the welding so that we can gain a better understanding of the non-destructive testing and this research design. These 6 major welding defects include slags, porosities, cracks, lump, lack of fusion, and lack of penetration. So we can see the locations of these defects inside the components. Due to the fact that the radiography is radioactive, many studies have been done before in order to test the feasibility of the replacement of radiography by ultrasonics. A study conducted by Sutherland and Weckerman and Raj in 2006 indicated the feasibility, but a lack of diverse thickness and defects in that study makes that study unconvincing. Similarly, another study undertaken by Buxton and Guangqi in 2004 and 2013 also indicated the feasibility, but being deficient in various materials and testing parameters also makes this study unconvincing and less persuasive. What's more, some other studies have been done in order to test the feasibility of replacement of radiography by phased array. One study conducted by Healthy Boom in 2014 verified this feasibility and recommended adding QFD as auxiliary testing method because, as we know, there are some certain dead zone areas in the near surface so that the phased array cannot test this area. Also, however, lack welding methods and defects such as superimposition also makes this study unpersuasive. According to the previous literature review, I proposed my research design based on the limitation in the previous studies in this field. Firstly, I will prepare apparatuses, calibration blocks, density gauge for radiography, phased array, and TUFD respectively. Secondly, I will add more kinds of defects and welding methods in order to make my research design more convincing and persuasive. Thirdly, I will use 3 kinds of metallic materials, including the mild material, the medium carbon steel, the high carbon steel. Fourthly, defects will include a lot of types, including those with multi-dimension or superimposition. Lastly, the thickness of the samples will cover a wide range, so that this research design will meet its intended purpose. When it comes to steps, firstly, we need to artificially create the samples with the artificial defects embedded into the samples. Secondly, we will need to compile data gained by the radiographies. Then we will use both phased array and TUFD to test the samples. Lastly, and the most importantly, we will need to compare the results gained by the radiography and those gained by phased array and TUFD in order to test the feasibility of this research design. There are some advantages in this research design. Firstly, I cover many materials they commonly used, unlike some studies conducted before, which didn't contain many materials. Secondly, I cover 4 commonly used welding methods. Thirdly, I cover a wide range of thickness in welding samples, which makes my research design more or less persuasive. The comparison between results are relatively objective and unconvincing. These are the advantages in my research design. However, there are also some disadvantages in my research design. Firstly, the weld bead can be accessed through both sides, which is much different from the actual field condition. Secondly, the defects created are artificial, which is also much different from the defects in the real components or materials. Thirdly, although many materials are included in my research design, but there are also many other materials that need to be taken into consideration. Lastly, 4 welding methods are not sufficient, so further research needs to be done to perfect the research design. Overall, the results of my research design is promising and more persuasive and convincing than the studies conducted in the literature review. So I think this research design can be copied by the professionals in the same field. So thank you for listening to my presentation.